Hi, everybody. It's Miss Rose, and this is week 23, lesson 2. I'm going to refresh your memory on the Pythagorean theorem in this lesson. One important thing about the Pythagorean theorem is that you can only use it with right triangles, and it's when you're trying to find a missing side in a right triangle. Here's a little picture to refresh your memory on some vocabulary. The two sides that make up the right angle are called the legs. And then the side that's opposite the right angle, the longest side in the right triangle, is called the hypotenuse. So those are going to be some really important terms as we talk about this formula. One cool thing about the Pythagorean theorem is that it can be proven in a million different ways. And that's something that unfortunately we're not going to have time to look at. But if you're interested, it would be worth Googling. There's former presidents that have come up with proofs. There's geometric proofs. There's algebraic proofs. And some of them involve similar triangles like we just did in the last unit. So unfortunately, we're not going to have time to take a look at that. But if you're interested, it would be worth looking up. So let's identify first in these couple of examples which sides are the legs and which side is the hypotenuse. So remember what I said, the two legs are the sides that make up the right angle. So we've got 12 as a leg and 5 as a leg. And then the hypotenuse is the longest side of the triangle. It's always opposite the right angle. So that's the hypotenuse. The formula, you might have learned it like a squared plus b squared equals c squared. We prefer looking at it like leg squared plus leg squared equals hypotenuse squared. That way, just in case anything's ever labeled with an A, B, or C, that won't mix you up. So it's better to think of the formula in terms of the vocabulary instead of just random letters. So we're going to go leg squared plus leg squared. That's 5 squared plus 12 squared equals the hypotenuse squared. The hypotenuse is just x. So what you're going to do in your calculator or in your head is you're going to do 5 squared, which is the same as 5 times 5. And then you're going to do 12 squared. That's like 12 times 12. And then because they're on the same side of the equal sign, I'm just going to add them up. And here's what's different. Sometimes people forget the last step. 169 would be way too big of a side length for a triangle where the other sides are 5 and 12. The 169 isn't the x, it's x squared. So you have to figure out what number you can square to get 169. So in order to figure that out, you want to square root it. So you want to grab your calculator and do the square root. Okay, I typed something in wrong. Square root of 169. Remember that you have this graphing calculator on your Chromebook, or you just looked at how to use the calculator in Desmos. That might be a nice tool as well. So 13 is the missing side. Is 13 the longest side in the triangle? Yes, the hypotenuse is always the longest side. So if your answer wasn't bigger than 5 or 12, that would be a problem. All right, number 2. This time we're going to be looking for a missing leg instead of the hypotenuse. So I could set up the Pythagorean theorem all over again, but wait a second, I'm noticing something from the last problem. 5, 10. 13, 26. It's just a similar triangle to the first one that we just did. So if 5, 12, and 13 are side lengths in a right triangle, then if this one's 10 and 26, I can just double the 12 and get 24 for y without even doing any work. Just so you know, most of the time that you do Pythagorean theorem, you come up with messy decimal answers. So if you ever see a nice combination of numbers like 5, 12, and 13, it's worth making a special note of and memorizing because those numbers are going to come up for the rest of your math career forever. And because of similar triangles, any multiples of those numbers work too. So 5, 12, and 13 make up a right triangle. 50, 120, and 130 would be a right triangle also. We just saw 10, 24, 26. So feel free to use these forever. And if you don't show your work, we won't even be mad at you. So you can, anytime that a nice combination of numbers comes up, make a list of them somewhere and keep them and look for them to pop up in problems for the whole rest of the year and the years to come. All right, I see a 12 again, but darn, this isn't a 13, so we can't just steal our combination of numbers again. So we actually do need to do the Pythagorean theorem again. So let's identify which sides are our legs and then which one's the longest one across from the right angle, and that's the hypotenuse. So remember that it has to be leg squared plus leg squared in either order. So I'm going to go z squared plus 12 squared equals 16 squared. 12 squared is 12 times 12, which is 144. And then 16 squared, we can do that in our calculator. Go either 16 squared or 16 times 16. It's 256. This time, we actually have to solve for z, so we have to go minus 144 on both sides. Let's see what 256 minus 144 is. 112. All right, we can take the square root of that, and that will give us our side length. So I'm going to go square root of 112. And oh no, just like I said, most of the time these come out to be messy values. So this is not one of our nice combinations of numbers, which are called Pythagorean triples. This is a messy decimal. So z doesn't equal 10.583, but z is approximately equal to 10.583. So that is the decimal approximation. But we just taught you about simplifying radicals. So we would love to sometimes see the decimal approximation, and then sometimes we would love to see what the exact answer is in simplified radical form. So we want to take our 112 and do what we just learned about and start looking for perfect squares that go evenly into 112. So I'm going to try maybe 36. All right, darn, that one doesn't work. Let me try 16. Oh, that one works. 16 and 7. So let me switch colors. I can go 112 and split it into 16 times 7. And then 16, that's the perfect one. 16 is a perfect square. It was perfect, so it can come out of its little radical house and you can square root it. Square root of 16 is 4. Square root of 7 is messy, so it has to stay in the house. So z is about 10.583, but it's exactly 4 root 7. So that's an exact answer. So if we ask you for an exact answer, give us the square root. If we ask you for a decimal approximation, that's when we want you to type it into the calculator. All right, let's try a couple more things. Ooh, all right. This one is just a Pythagorean theorem problem, but the sides are radicals. So how are we going to deal with that? So first off, again, figure out which sides are the legs and which side is the hypotenuse. And then we're going to have to figure out how to plug these messy square roots into the Pythagorean theorem. So root 14 squared, 5 root 2 squared equals y squared. Good news though, there's a really easy way to square a square root. They just cancel each other out. So here's what I mean. If I do square root of 14 and then I square it, I just get the 14. The square and the square root undo each other. Here's where you have to be very careful though. Sometimes people accidentally go, oh, root 2 squared, that's 2, 5 times 2. But you have to square everything. So if you're putting that in your calculator, make sure that you use parentheses. Parentheses 5 root 2, parenthesis, and then square it. It's not 5 times 2, it's 25 times 2. So it's 50. I guess another way around that is you could go 5 root 2. Instead of going squared, you could just go times 5 root 2. That might be a nice way to avoid typing it in wrong by mistake. All right, 14 and 50, those are on the same side of the equal sign. So I'm just going to add them, combine the like terms. 64, I recognize that from our list of perfect squares. So if you square root 64, what times itself gives you 64? 8. 8 times 8 is 64. So that's your final answer. Sometimes people panic, like that's the hypotenuse. It was supposed to be the longest side, but this is a root 14. Remember, this is root 14. That's a regular 8. So 8 is a lot bigger than the square root of 14 is. All right, let's try a couple more. What we're going to be seeing throughout the rest of the year is looking at other shapes and sometimes having to use the Pythagorean theorem to help us find like areas and stuff like that. So I wanted to do a couple of those examples too. So the first one will be pretty quick. It's a rectangle. We want to find the perimeter, so we're going to have to find a missing side. And you might be wondering why we can do Pythagorean theorem, because Pythagorean theorem is only for right triangles. But look, there is a right triangle. And be really careful here. The 5, that one's the hypotenuse. The x and the 4 are the legs. So I'm going to go leg squared plus leg squared equals hypotenuse squared. All right, x squared plus 4 times 4, 16. 5 times 5, 25. And then this is another one of these problems where you have to solve for x. So I have to go minus 16. X squared equals 9. I remember 9 from our list of perfect squares also. Square root of 9 comes out to be 3, because 3 times 3 is 9. And oh, that's surprising. That was a whole number. So that's another one to take note of. There was 3, 4, 5. It's actually the most common of those Pythagorean triples. So write that down. So far we have 3, 4, 5, and we have 5, 12, 13. Those are our magic combinations. If it comes up again, you don't even have to show work. 3, 4, 5, 6, 8, 10, 9, 12, 15. Any combination is fine. And then this problem actually asks you to find the perimeter of the rectangle. So if that side is 3, if it's a rectangle, then opposite sides are congruent. So I have 3 plus 4 plus 3 plus 4, which is 14. All right, let's do one more problem, but with a shape that's a little bit more complicated. What about an isosceles trapezoid? So here's the problem with this one is I don't know this leg and I don't know this hypotenuse. So all I have is one side of the triangle and I normally need 2. But good news, you can find one of the other sides. So here's a key detail. Not only do you want to drop this height down, you have to drop this height down also. And then it makes a little rectangle shape in the middle. And rectangles have opposite sides that are congruent, so I can just steal this 9 and bring it down. The whole base is 25, so I'm going to go 25 minus 9, that's 16. So there's 16 left over for these 2 little segments over here. Since there's 2 congruent segments left over because it's isosceles, I'm going to divide by 2, and it's 8 and 8. So now I'm ready to do Pythagorean theorem. Now I have a leg, and I'm going to be looking for the hypotenuse. I'm going to call it x. It's my hypotenuse. I'm going to go leg squared plus leg squared equals hypotenuse squared. 8 squared, 8 times 8 is 64. 15 squared, 15 times 15, 225. They're together on the same side of the equal signs. I'm going to add them up. 64 and 225 is 289. And then don't forget, last step is you always square root to find the missing side. So 289, is that going to be a perfect square or is that going to be a messy one? Oh, it's a perfect square. Let's add that to the list. 17, what were the legs? 8 and 15. So let's add that to the list. 8, 15, 17. Anytime these numbers come up in the future, you don't even have to show your work. You can just memorize this list and just use them because we already did the work. You don't have to keep doing that same Pythagorean theorem over and over again. All right, final answer is what's the perimeter? Perimeter, you only want to add up the sides on the outside. Like, don't add this height in there. I just want the 17, the 9, the 17, and then this whole segment, which remember was 25, or I could add up all the little pieces. So the perimeter was 17, 9, 17, and 25. Let's see what that equals all together. 17 plus 9 plus 17 plus 25 for a total perimeter of 68. So that's your intro to Pythagorean theorem. You saw how sometimes we're going to get nice Pythagorean triple whole number answers. Sometimes we're going to get decimal answers. Sometimes we have to use square roots in our Pythagorean theorem, and sometimes we're going to be using Pythagorean theorem with other shapes. So try out the homework, and I promise in the weeks to come, we're going to have lots and lots of practice with this Pythagorean theorem. This is probably the most important geometric theorem that there is. So it's really, really, really important that we practice this a lot and learn it well. Let me know if you have questions. Bye.